Welcome, Wapplers from around the world. This is June 2026 Wappler Meetup. And today we have a very special video by a very special guest, Mr. Glenn Plaisir from Down Under in Australia. And we do these Wapplers once a month on the second Friday of every month. You can find links and keep track of them on the forum. If you've got something you'd like to share or present, please reach out. We'd love to hear from you. All right, we have, let's see here. Writing Wappler-extensions by Ben Plaisir. And here we go.
If you've ever wanted to create your own reusable, data-driven UI widgets that work natively inside Wappler, with property panels, dynamic bindings, and full App Connect integration, then this series is for you. Over 4 videos, we're going to build a star rating component completely from scratch and publish it as a proper installable Wappler extension. By the end, you'll be able to install it into any Wappler project via the Extensions Manager and have it behave just like any other built-in Wappler component. What is a Wappler App Connect component? Wappler's front-end framework is called App Connect. It's the engine behind all those DMX attributes and DMX tags you see on your pages. Every component you use, Server Connect, Data Store, repeaters, modals, they're all App Connect components under the hood. An App Connect component is essentially a self-contained JavaScript module that registers itself with the App Connect runtime. Once registered, it gets its own reactive data scope. Other components and bindings on the page can read from it. Can expose actions that event handlers can call, things like setValue. Can respond to dynamic attributes, so you can bind data into it with DMX bind. Gets a full component descriptor, so Wappler's UI knows exactly what properties, actions, and events it has. Think of it as the difference between a dumb HTML element and a living, breathing piece of your application. The extension package folder structure. You can choose your own folder structure for the extensions, with just a few requirements. It has to be a subfolder of your project, like for example _src/ your extension name. It has to have package.json as any other node module, declaring the package general name, version and dependencies. For App Connect components, it has to have a folder with the UI definition file in it, like appconnect/components.hjson. For Server Connect extensions, it has to have a folder with the UI definition file in it, like server_connect/modules/extensionname.hjson. Wappler has greatly simplified the initial setup of an extension folder by going to your project settings, choose extensions and choose to create new extension. Then just pick a folder to place your extension in. In this case I choose to create a new folder with a leading underscore showing that the folder is not part of the project files. I have set all folders with a leading underscore to be ignored when publishing the site. Inside the new folder, I create another folder, this time with a leading @ sign followed by the npm publisher's username name. The last folder created starts with Wappler followed by the component name. The Wappler part is important for easy recognition. Saving the new extension and applying it makes Wappler grumble for a bit. As a result, see that a new folder and files were created by Wappler. The first file is in an App Connect folder and has some content. We will be discussing this further in the third video. The second file that was created is the node package.json file. Notice the name? This is for the scoped npm package. This file will be further discussed and extended in the fourth video. For now we will leave this part as is. We have laid the basis for our widget. Oops. Sorry, I meant to say, component. Before I forget, let's have a look at the node modules folder. Here we see our scoped package with the same file structure as in our working copy. In other words, Wappler has performed an npm run command and installed our package like any other npm package. In fact, when we go to the package.json file in the root directory, we see that we are also mentioned in there. Let me give you a quick roadmap of what we're building across the 4 videos. Video 1, this one, is the introduction. It covers the concepts, structure, and the plan. Video 2, building the JavaScript. We'll write star rating.js from top to bottom, registering the component, defining attributes, writing the render function, wiring up click events, exposing actions, and firing the change event. Video 3, building the component descriptor. We'll write components.hjson, defining every property, action, and event so that Wappler's IDE knows exactly how to present the component and its panels. Video 4, putting it all together. We'll write the package.json, look at what the Wappler metadata block needs to contain, install the extension into a real Wappler project using the extensions manager, drop the widget onto a page, bind it to data, and watch it work end to end. So, what is the star rating widget actually going to do? Renders 1 to 5 stars, or however many you configure via the max property. It exposes a value property, bind DMX bind value to feed it data directly from a database query. The user can click a star to set a rating. It fires a change event, so when the user picks a rating, you can immediately trigger a server action to save it. It has a set value action, set its value programmatically from a flow or event handler. It has a reset action, clear the rating back to 0. It supports a read-only property, use it as a display-only widget, for example showing average ratings in a product listing. Simple enough to follow clearly, real enough to cover every major concept you'll need for any component you build in the future. In the next video we'll dive straight into the JavaScript, registering the component with App Connect and building it up step by step.
Wow. Oh, wow. Ben, you've outdone yourself.
Thank you. Have you got any questions?
Yeah, I think that first part's fairly straight. But one thing, and it's just something that's come to mind from having done one or two app connects in the past. When you create your SRC folder and then you use the package creator, shall we say, the project to create your extension, it appears both in the node modules and the SRC. Would I be right in saying, from my recollection, that actually one is just a symbolic or virtual folder? The other, seem to remember that if I edited the code in the SRC, it automatically reflected within the node modules. Have you noticed that, Ben? I might be wrong there. It's just from, when you get one of those strange memories from the long distant past.
Yeah. Well, in the coming videos, you'll see that I reload the extension to update the npm package. When you're developing in the SRC folder, you're only developing that part of it, and it does not affect the rest of the process until the widget has been saved.
Got you. That's obviously a false memory from me. Then I seem to recollect I had an issue when I edited one, the other one was automatically reflecting the changes as if it was a clone directory, a symbolic directory. But maybe it's just my memory wrong on that one, Ben.
Yeah, well, you'll see it in the coming videos, the way that it works. But to start off with, it's very, very simple using Wappler.
Yeah. Obviously, I followed exactly what you were saying there. Just had this lurking memory about I had an issue where changing one actually reflected in the npm directory as well, or the node directory, but maybe not.
All right. Well, I had one question that's, I think, unrelated to the extension. You had mentioned that the underscore source file was not being uploaded. Is that not being uploaded to Git or not being uploaded to the server?
Not uploaded to the server.
Sure.
Well, to the remote, that is.
Right.
You'll have it on your local server, but you'll have to configure that in the configuration file. Like I'm using Docker at the moment, so I use Docker ignore. But with your FTP, you'd have to put that in as a file that should not be uploaded, should be ignored.
That makes sense.
Well, actually, when you FTP a site, the npm package folder is not uploaded. And in the same manner, the src file will not be uploaded.
Okay, cool. All right. Well, I'm excited to move on to video 2. You guys ready? Okay, building the JavaScript.
Welcome to video 2. In the last video we covered what an app connect component is, how the extension package is structured, and what we're going to build. In this video we're writing the JavaScript, the file that makes the star rating widget actually work. By the end of this video, we'll have a fully functional component that renders stars, responds to clicks, exposes a value to app connect's data scope, fires a change event, and supports read-only mode. Let's first create a new folder within our widgets folder. This folder is called includes. Inside that folder, we create a file called star-rating.js and build it from top to bottom. Before we write a single line, it's important to understand that this file actually contains two separate but connected things. The first is a standard web component, a native browser custom element. This is what handles the actual DOM, rendering the stars, listening for clicks, managing the shadow DOM. The second is the app connect wrapper. This is what connects the custom element to Wappler's reactive data system, giving it properties, actions, and events that the rest of the page can work with. Think of it as an engine and a gearbox. The web component is the engine, it does the mechanical work. The app connect wrapper is the gearbox, it connects that engine to the rest of the vehicle. We'll write the web component first, then wrap it with app connect. We start by defining a class called star rating that extends HTML element. That's the base for all custom elements in the browser. The observed attributes getter tells the browser which HTML attributes this element cares about. Whenever rating, max, or read-only change on the element, the browser will call attribute changed callback, which we'll see shortly. Next is connected callback. This fires when the element is inserted into the DOM. We attach a shadow DOM. This gives the component its own isolated DOM tree and its own scope CSS. Nothing outside can accidentally style our stars, and our styles can't leak out into the page. If there is no shadow root guard, means we only do this setup once, even if the element is moved in the DOM. We inject the CSS directly into the shadow root. The host selector styles the custom element itself. We make it an inline flex container, so the stars sit neatly in a row. Active stars are gold, inactive stars are silver, and hovering turns them goldenrod. All scoped, all isolated. Take special note of the placement of the backticks. Then we create a container span for the stars, append it to the shadow root, and attach our click handler, binding this so it always has the right context. Attribute changed callback and disconnected callback. When any of our observed attributes change, we just call render, which redraws the stars to reflect the new state. Clean and simple. Disconnected callback is the cleanup hook. When the element is removed from the DOM, we detach the click listener to avoid memory leaks. Set value takes any numeric input, converts it to a safe rating, updates the component's attribute, and re-renders the stars. The helper methods. We have 3 small private helpers that keep the rest of the code readable. GetMax reads the max attribute and defaults to 5. GetRating reads the rating attribute and clamps it between 0 and max, so we can never have a rating of 7 out of 5. And isRead only checks for the read-only attribute. Importantly, it also checks that it isn't explicitly set to the string false, because in HTML, just having the attribute present is truthy. The render method. Render is the heart of the web component. It reads the current max and rating values and draws the stars. Notice the efficiency here. We only rebuild the star elements if the number of stars has changed. Otherwise we just update the active class on each one. This avoids unnecessary DOM thrashing every time the rating updates. Each star gets a data index attribute. That's how we'll know which star was clicked. We also update the cursor, default in read-only mode, pointer when interactive. The click handler. On click uses closest to find the click star. This is robust even if the click lands on a child element. The very first thing it does is check is read-only and bail out immediately if true. That's how read-only is enforced at the interaction level. Finally, we register the custom element with the browser, with a guard to make sure we don't register it twice. Now that our web component is complete, it's time to see it in action inside Wappler. First, open the extension we created in the first video. Save it. This refreshes the extension so Wappler picks up the latest version. Next, using the registered name of the component, we drop it into a content page just like any other element. And there it is. The component renders exactly as expected. We now have a fully functioning web component running inside Wappler. The final step is to connect it to App Connect so it becomes reactive and fully integrated with the rest of the page. Now we come to the second half of the file, the DMX component call. This is what turns our custom element into a fully integrated Wappler component. The name we pass here, star rating, must match the tag name we registered with custom elements define. Wappler will look for star rating elements in the page and attach this component to them. Initial data defines what this component exposes to App Connect's data scope, the values that other components and bindings on the page can read. We expose a single property, value. This is what you'd bind to with DMX bind value or reference in expressions as my rating value. The attributes object declares the bindable properties of the component. Each one has a type and a default value. Rating is the current value. This is what you'll bind dynamic data to. Max sets how many stars to display. Read only prevents user interaction. Declaring them here is what makes DMX bind rating, DMX bind max, and DMX bind read only work on the page. Methods are the actions this component exposes to App Connect. Whatever you define here shows up in Wappler's action picker, things you can call from event handlers, flows, and workflows. Set value is the one action we expose. Notice it accesses this props max. That's how you read the current value of a declared attribute inside the App Connect wrapper. And this node gives us a reference to the actual DOM element, our star rating custom element, so we can set attributes on it directly. The render function runs once when the component is first initialized. We do two things here. First, we sync the initial value into App Connect's data scope using this set. This is the method you always use to update a component's reactive data, never assign directly. Second, we set up a mutation observer. This is the bridge between the web component world and the App Connect world. Our custom element manages the rating attribute itself. It changes it whenever the user clicks a star. The mutation observer watches for exactly that change, and when it sees it, it calls this set, value, v, to push the new value into App Connect's data scope, and this dispatch event change to fire the change event that other components can listen to. This is the key insight of this whole file. The mutation observer is the bridge. The web component handles the UI and the attribute, the mutation observer detects the change, and App Connect picks it up from there. Update is called by App Connect whenever one of the declared attributes changes, for example when a DMX bind, rating binding delivers a new value from a database query. The fields parameter is a set of which attribute names actually changed, so we only do work for what actually needs updating. This is an important performance pattern, always check fields as before acting. For rating and max we push the new value down to the custom element via set attribute. For read only we either set or remove the attribute, because that's how Boolean HTML attributes work. Finally, destroy is the App Connect lifecycle cleanup hook, called when the component is removed from the page. We disconnect and null out the mutation observer. Always clean up after yourself. Observers and event listeners that aren't cleaned up are memory leaks waiting to happen. And that's the complete JavaScript file. We have a fully functional star rating custom element wired up to App Connect's data scope, with reactive attributes, a set value action, a change event, and proper read-only support. In video 3 we'll write the component's HJSON file, the descriptor that makes all of this visible and configurable inside Wappler's IDE. See you there.
Thank you, Ben Pleasure.
Yeah, I think I'll have to watch that about another 25 times before it'll become second nature. I follow it, but I couldn't sit down and write one without using it as reference. It's going to be a really, really valuable reference guide.
This is the classic useful video that you can just play 10 seconds, pause it, leave a freeze frame on screen, do what you've got to do, press play, do a bit more, and just refer back to it every time you need to. Because making extensions, we're just not doing on a daily basis. So the muscle memory is not going to be there. But reference like this is spot on.
Wow. Then I'm blown away, absolutely blown away. So, do we want to go on to video number 3 while we're at it?
I think so.
All right. I'll give your host just a second to get organized here.
Welcome to video 3.
Okay. Yeah, video 3. That was perfect.
That was very short.
Yeah, well,
I reckon I could do that.
That was the how not to do it video.
There we go.
Welcome to video 3. In the last video we built the JavaScript, the engine that makes the star rating widget work in the browser. In this video we're writing the component descriptor, the components.hjson file that makes the widget visible, configurable, and fully integrated inside Wappler's IDE. This is the file that gives your component its property panel, its action picker entry, its event listing, and its drag and drop template. Without it, Wappler doesn't know your component exists. When Wappler created this file in video 1, it created 3 top-level arrays as shown here. In fact, when we have a look at the Wappler properties panel, we see that we should add another array to this skeleton, namely static events. Let me go ahead and include the 4th array. Components is where our widget lives. This is the main array and it's where we'll spend almost all of our time. A single components.hjson file can define multiple components if the extension provides more than one. Attributes and events are for declaring dynamic attributes and events that extend existing Wappler components, for example if you wanted to add a new attribute to every form input. We don't need those for our widget, so they stay empty. Static events is for events that apply statically to existing elements. Also empty for us. Everything interesting is inside components. The first block is all about identity, telling Wappler what this component is and how to find it in the DOM. Type is the component's internal identifier. It must match the name we registered with DMX component in the JavaScript. Selector is the CSS selector Wappler uses to detect this component on the page. We support 2 forms, a star rating custom element with his DMX star rating, and any element with his DMX star rating. This gives flexibility in how the component can be used in markup. Base name is the default prefix Wappler uses when auto-generating an id for a new instance, so the first one you drop on the page becomes rating 1, the second rating 2, and so on. The next block controls how the component appears in Wappler's panels. Group title and group icon control which group the component appears under in the insert panel. We're putting it under widgets with a star icon from Font Awesome. Title is the label shown in the structure panel for each instance. The id token is a Wappler placeholder. It gets replaced with the component's actual id at runtime, so you'll see star rating, rating 1 in the tree, which is much more useful than just star rating. Icon is the small icon shown next to it in the structure panel. State, open, means the component starts expanded in the structure panel. Any parent, true, means the component can be dropped inside any container on the page. It has no restrictions on where it can be placed. The insert template is one of the most important fields in the whole descriptor. Template is the HTML that gets inserted into the page when you drag the component from the insert panel onto the canvas. Wappler replaces the ID token with the auto-generated id. Notice what's in there. The star rating custom element tag is DMX star rating. This is what connects it to the app connect component. A sensible default rating of 0 and max of 5. Getting the template right matters. It's the starting point every developer sees the first time they use the component. Set sensible defaults and include only what's necessary. Data schema and output fields define what the component exposes to App Connect's data scope, the values other components and bindings can read. Data scheme mirrors the initial data we declared in the JavaScript. We expose one property, value, typed as a number. This is what you'd reference as rating 1 value in a binding or expression elsewhere on the page. Wappler uses this schema to power its autocomplete and data binding panels. Output equals type, object, tells Wappler that the component's data scope is a single object, as opposed to an array, which would be the case for a repeater or list component. Data pick, false, means this component doesn't appear in the data picker as a standalone selectable data source, because it's a UI widget, not a data provider. The properties array defines every field that appears in the properties panel on the right-hand side of Wappler when you select the component. They're organized into named groups. Every component must have an ID property, it's always first. Name is the internal identifier, attribute is the HTML attribute it maps to, title is the label shown in the panel, and help is the tooltip text. Required, true means Wappler will flag it if it's missing. Notice that name and attribute can differ. Max stars is the internal property name, but it maps to the max HTML attribute. This is useful when you want a more descriptive label in the panel than the raw attribute name. The type field drives the input control Wappler shows. Number gives a numeric input, Boolean gives a toggle switch. Wappler picks the right UI automatically based on type. Each property declared here is automatically also available as a DMX bind dynamic attribute, so DMX bind rating, DMX bind max, and DMX bind read only all work without any extra declaration. Action scheme defines the actions that appear in Wappler's action picker, the things a developer can call from an event handler or a flow. We expose one action, set value. The name must exactly match the method name in the method's object in the JavaScript. The parameters array defines what inputs the action expects. Wappler will show a parameter input field for each one in the action editor. So, when a developer opens an event handler and types rating 1, they'll see set equals value in the autocomplete, and when they select it, Wappler will prompt them for the value parameter. All driven entirely by this descriptor. Finally, the events array declares the events this component can fire. We declare one event, change. The name must match exactly what we pass to this dispatch event in the JavaScript. Once declared here, DMX on change becomes available on the component in Wappler's event panel. A developer can wire it up to any action, server call, or flow without writing a single line of JavaScript. The last two fields are critical for how Wappler handles the JavaScript file when the extension is installed. Copy files tells Wappler to copy the JavaScript file from the extension package into the project's public JavaScript folder. This is how the file ends up somewhere the browser can actually load it. Link files tells Wappler to inject a script tag referencing that file into any page that uses this component. The defer true flag means it loads without blocking page rendering. Together these two fields are the mechanism that makes the extension self-installing. The developer never has to manually copy a file or add a script tag. Wappler handles it all the moment the component is dropped onto a page. Last of all, we discuss the attributes section. The attributes array is where you teach Wappler's UI about dynamic data bindings, specifically, how to let a developer connect a live data expression to one of your component's HTML attributes. A walk through the code shows. Name, star rating rating. A unique identifier for this attribute entry. It's internal, the user never sees it, but it must be unique across all attribute definitions in your component. Attribute starts with DMX bind. Attribute rating. Together these tell Wappler, I'm describing the DMX bind rating attribute. The attribute starts with as the prefix, DMX bind, and attribute is the suffix. They combine to form the full attribute name on the HTML element. Title, rating. Type, Boolean. Display, field set. Group enabler, true. This makes the entry appear as a toggle group in the properties panel, a collapsible section with an on/off switch. When the developer flips it on, the child controls appear. Type, Boolean and group enabler, true work together to create that toggle behavior. Show, rating, value. No change on hide, true. Show declares which child fields become visible when the toggle is enabled. No change on hide means that if the developer collapses or disables the group, the existing attribute value on the element is preserved rather than cleared. Icon, group title, group, icon. These control the visual presentation in the panel. The icon next to the entry and the group heading it appears under. Allowed, on, star rating, true. This is a scope guard. It tells Wappler to only show this dynamic binding option when the selected element is a star rating component. It won't appear on unrelated elements. The child entry, rating, value. Is value, true. Data bindings, true. Type, text. Init display, none. This is the actual input field that appears inside the toggle group. Is value true marks it as the real value carrier. The expression the developer types here gets written as the value of DMX bind rating. Data bindings, true activates Wappler's data picker so the developer can visually browse and select data sources. Init display, none keeps it hidden until the parent toggle is switched on. The big picture. In short, the attributes section bridges the gap between static property inputs and dynamic live data bindings. And that's the complete components.hjson file. We've declared the component's identity, its UI presentation, its insert template, its data schema, all 4 properties, 1 action, and 1 event, and we've told Wappler exactly how to handle the JavaScript file. With our JS and HJSON files now complete, the moment has arrived to let the star rating widget take its rightful place inside Wappler. First, save the widget. This ensures both files are updated for Wappler's use, including the JavaScript file, which must be refreshed. When the update dialog appears, simply click Update to apply the changes. Next, open the Structure panel and choose where you want the widget to appear. Select Widgets, then choose Star Rating. Wappler inserts the component into your code, and the stars immediately appear in Design View. At this point, we can finally admire the result, the pinnacle of our efforts. In Video 4 we'll bring everything together. We'll look at the package.json, publish the package to npm, install it into a real Wappler project using the extensions manager, drop it onto a page, bind it to live data, and watch the whole thing work end to end. In the last 3 stages we wrote all the code. We have a custom element, an app connect wrapper, and a components.hjson that describes the whole thing to Wappler's UI. It works in our test project. But right now, it only works because the files happen to be sitting in the right folder. It's not a real extension yet. A real extension is something you can hand to someone else, or publish to npm, and they can install it in 1 click from the extensions manager. That's what this stage is about. We'll complete package.json, write the README and the license, publish to npm, and then install the extension into a real Wappler project, using the extensions manager. By the end, you'll drop a star rating widget onto a page, bind it to live data, and watch the whole thing work end to end. First, the package.json. Open package.json. This is a standard npm package file, but there are a few fields that Wappler specifically looks for. The name, @benplay/Wappler star rating, is a scope name. This isn't required, but it's good practice. It namespaces your work and avoids collisions with unrelated packages that might also be called star rating. The version is 1.0.0. Wappler's extensions manager uses Semver to track installed versions and detect updates, so keeping these accurate matters. When you fix a bug or add a property, bump the version before you publish. Add a description, something concise, like an interactive star rating widget for Wappler App Connect. Add an author field with your name and optionally your website or email. The keywords array includes Wappler-extension. That's the signal Wappler uses to recognize the package as an extension in the extensions manager search. Without it, the package won't appear in results when someone searches for it. The engines field specifies Wappler, greater than equals 4.0.0. This tells the extensions manager which Wappler versions your extension is compatible with. Publish config sets access, public. Because this is a scoped package, npm defaults to treating it as private, which means publishing would fail unless you're on a paid plan. This line overrides that and marks it as public. Finally, files whitelists exactly what gets included in the published package. No other files will be included even if they are inside Wappler star rating. Next comes the README markdown file. The README file is the first thing developers see on npm. It is automatically displayed on the package page. This makes the package look finished and professional. Here I could say, create readme.md in the root of the package. Start with a short 1-paragraph description of what the component does. Then a quick installation section. Then a properties table. Etc. But hey, why go through all of this when we have the option to use AI? Here I have chosen to use Claude Sonnet 4.6. This is the instruction that I give to AI. Create the README markdown file for Wappler star rating located in the _src directory. It must include versioning, and make sure that the installation uses Wappler-extension manager. I've sped up this part of the video to keep things moving and avoid dragging out the suspense. Once the AI finishes generating the README and saves it, Wappler shows a summary of the document. Feel free to pause the video and read through it in detail later. For now, I'll simply accept the changes and continue. Just keep in mind, you should always review what the AI produces. It's incredibly helpful, but not always perfectly accurate, so a quick sanity check is essential. The last file to be created is the license markdown. This time we instruct AI to create the license markdown file for the same package. Why a license should be included. 1. Without a license, your code is not legally usable. This is the part many developers don't realize. If you publish code without a license, nobody has the legal right to use, modify, or redistribute it, even if you intend it to be open source. 2. It protects you. A license limits your liability, clarifies that the software is provided as is, prevents legal disputes. MIT, for example, explicitly states you're not responsible for damages. 3. It protects users. Developers and companies need to know, can they use it commercially? Can they modify it? Can they redistribute it? A license answers all of that. 4. It's required for many ecosystems. Some companies, CI and CD systems reject packages without a license. 5. It builds trust. A license shows you're serious about maintaining a proper open source package. Now that we've prepared all the files needed to publish our widget to NPM, we're ready for the final step. First, open your terminal and navigate to the package folder. Next, log into NPM. Then, run the publish command. And that's it. Your widget is now an official Wappler App Connect extension. To confirm, open the Extensions Manager and search for star rating. You'll see it listed, ready to install. You can also open its details to view the information included in the package. When you do, the README appears right away. From this point on, any Wappler user can install the extension in a single step. Installing, using the Extensions Manager. Here I have opened a clean Wappler project. A Node.js project because I find it the easiest to work with. But this could be any server model, because there is no server action required for this widget. Make sure that you use the own server option as opposed to the Wappler local server. From here, go to Extensions Manager. Search for star rating or at Ben Play. The package appears because of the Wappler extension keyword. Click Install and Save. Wappler runs npm, installs the widget behind the scenes, registers the component definition, and copies star rating.js into the project's public folder, because that's what the copy files entry in the HJSON tells it to do. The link files entry then ensures the script tag is injected into any page that uses the component. In the case of Node.js, this will be in the main layout page. Let's now add a widget to our page. La Taberna has a user-defined rating, one where the user gives their star rating. Choose the spot where the widget is to appear, select Widgets, and Star Rating. As you can see, this works like a charm. Next comes a static rating, one where the developer assigns the number of stars. We enter 5 and tick the read-only box. This also works as expected. The dynamic rating requires a dynamic value. The widget is inserted, after which we go to dynamic attributes. Here we choose star rating and rating. A star rating variable was previously assigned a value of 4. Hence the 4 stars that have now appeared. As with the static value, we make this a read-only value. As an afterthought, let us use the data binding to show the number of stars that have been selected. First, we add a span, inside which we place the text, stars. Preceding stars, we insert an app connect binding. Now, it could be that the values of the star ratings are not available at this stage. This is probably a problem with the widget code. However, restarting Wappler will solve the problem. In the data bindings panel, choose the value of rating 1. We will make a few design adjustments, namely a buffer between the stars and the value, as well as adding a flex container to align the stars with the text. Furthermore, let's only show the text when stars have been selected. And there we have it. A complete star rating widget that is flexible enough for most applications. A job well done. I hope this 4-part series has helped you get a real feel for the inner workings of Wappler's App Connect extension system. And if you're hungry for more, Hyperbytes, Brian English, has a fantastic series on Server Connect extensions waiting for you on Wappler's YouTube channel. Thanks for joining me on this journey.
Excellent.
Silence.
My response
Brilliant.
is the same as
Absolutely
from the previous
brilliant.
one.
Wow. That's amazing. And I love the commercial for Brian at the end. That's wonderful.
Yeah. He's my dad. He's got to do it.
Oh man. The very powerful, very, very powerful. And the ratings, especially real ratings these days, are going to become more and more critical for websites to be able to generate trust. So this is your timing is perfect. So, Ben, do you what are your plans about maintaining or updating this?
Well, as soon as I hear of a problem, I'll certainly be updating it. For the moment, it works. In the video, you also notice that I said that Wappler had to be restarted to see the values of the widgets. I'll be fixing that so that Wappler doesn't have to be restarted.
Yeah, I think it's fair to say with extensions, they're not something that just break, particularly App Connect extensions, because they're pure JavaScript. So unless JavaScript language depreciates part of the code, or Wappler changes the way that it interfaces with the extension, it's highly unlikely that it will break, as opposed to server extensions, which rely on an NPM. So if you're doing something like the series I did on IMAP, for instance, uses a extension or an NPM, that could potentially change and that could potentially break it. So I think App Connect are probably likely to be more secure long-term than a lot of the server extensions, which have specific NPM dependencies.
Makes sense. Well, that's awesome. Well, I, for one, am going to be spending the weekend reviewing the videos. So when you see the view count go up, it could possibly be me. Oh, that's wonderful. Well, I want to thank you all for joining us today. I want to thank Ben, especially for his fabulous videos, writing Wappler extensions. And we look forward to seeing everybody next month, the second Friday of the month, and we'll see you in the forums.